All right, let's tackle showing the editor when a TaskQueue item component is created. That's this thing right here. And also deleting that node if you don't enter any text when the editor closes. So let's go to our TaskQueue item component.cpp, go to the constructor, and let's just try to show the editor to begin with. Label.showEditor. And give it some blank text to display. Label.getCurrent text editor set text. Just give it some blank text. Let's try that out. See if it works. Oh, juice assertion failure. A component can only be focused when it's actually on the screen. If this fails, then you're probably trying to grab the focus, or maybe one of its parent components isn't visible yet. Okay, that makes sense. We can't show the editor yet because the TaskQueue item component isn't on the screen yet. All right, we have to find another workaround. All right, let's bail. Okay, so this clearly doesn't work. Let's get rid of that. To get around this, we need to show it after we're on screen and visible. One of the things that we're going to run into with this is that it's going to try to show the editor for the root level node. And whenever we create a new task list, we want the root level node's name to be the same name as the file that it is stored in. So we want to come up with a way to determine if this TaskQueue item component instance is representing the root node or not before showing the editor. We can use the async updater class to do this, as that doesn't start firing until the message manager is up and running. And the message manager doesn't start running until after the app window is on screen. Now, I'm going to write something that's similar to message manager call async and timer call after delay. It's going to use async updater to trigger a Lambda. And both of these are static functions, so we will do something similar. Just to show you what I mean by that is message manager call async. All right, we'll just take a look at this guy real quick. And it basically just has a Lambda that you can supply to it via this guy right here, and it calls that Lambda during the message callback. So it posts it to the message thread, and then when the message callback is fired, that's when it calls the Lambda. And then timer call after delay does something similar to that. Timer call after delay. That guy does a similar thing with a Lambda invoker. It's got a timer callback. It starts a timer automatically, and it deletes itself, but it's got a Lambda that you can pass to it, which it surprisingly does not check if that Lambda is null, which it probably should. Okay, so we're going to do something similar. Those are both static functions. So let's go up to the top, and let's write this thing right above our constructor. We'll do struct single Lambda callback. And we'll inherit from, let's just finish the stub. There's our struct. Let's inherit from async updater, private async updater. And let's add our async updater virtual function, void handle async update, override, stubber out. Let's give ourselves a Lambda to call, std function void func, like that. And while we are here, let's make ourselves non-copyable. Juice declare non-copyable with leak detector. If the callback exists, let's call it, and let's give ourselves a little debug message too. Debug. We'll do this. Name of the class, name of the function. Okay, now if func, and then we'll do the same delete. Delete this. So it's self-deleting. And actually, let's make this private. All this stuff will be private. Remember, we said we wanted this to be a static function. So we will use a static function to spawn it the same way that call after delay and call async work. We'll do the same thing here. So let's make our constructor private. And let's see, single Lambda callback. Give it a Lambda to pass in, void f, let's just move that argument into our func member. Func. And give it a body. All right, let's just trigger the update. Trigger async update. Now we just need a static function to call. So static void make, and we'll do this. And let's add our static function below the class. Void single, the callback make, return, no, not return, just new single lambda callback, and std move f. All right. So this is our little class that kind of emulates the way those other things, the way those timer call after delay and message manager call async work, except it uses async updater. All right, so now we can go to our constructor after we set these, set the completed buttons colors, and we can do, let's see, we can create our Lambda to fire after this GUI widget is on the screen. So let's be smart, and we'll use a safe pointer in the Lambda to prevent using a deleted this by accident. Inside of, when we call this guy, we'll use a component safe pointer to make sure that we still have a TaskQueue item component that we can work with. So single lambda callback, make, sorry, we're not doing that yet. We need to make our safe pointer first. Component safe pointer, TaskQueue item component, we'll call it safe pointer. Safe pointer, this. If you've ever poked around inside any of the button classes or any of the GUI widget classes, they have all this kind of stuff in there. Like you capture a safe pointer of it and make sure the thing you're trying to use still exists, because it might get deleted somewhere else for some reason that's out of your control. So we will do single lambda callback. Whoops, where did that go? Single lambda callback, this one. I'm calling the wrong thing. Single lambda callback make is the one. And now we provide our lambda like that. All right, lambda body starts here. We will take a copy of our safe pointer. Now we can just check if safe pointer dot get component, and now we can try to show it. Safe pointer label show editor, and then safe pointer label dot get current text editor set text, same blank text that we had before. Now lambdas capture everything as const, so we need to make this mutable to call the show editor function, as show editor is not a const function. Mutable. And our text turns green. Awesome. All right, let's run it and see if it works. Look at that, text editor. Awesome. That's fantastic. And we can edit. And if we add a task, it works. Awesome. All right, rad. Okay, good to go.